Welcome to an overview of carbon removal, bringing carbon dioxide from the sky down. By the end of this lecture, you'll be well versed in what carbon removal is and what the exciting opportunities are that exist in its wake. In just the last 5 years, the world has seen a 4,000-fold increase in the amount of total investment going towards carbon dioxide removal, CDR for short. If that trend continues to increase along that curve as I'd expect it to, this market will grow another 4 to 5 times in just the next 4 years, as presented in this curve. If you knew that an emerging market had this kind of growth potential, wouldn't you want to join in? Hi, my name is Clea Kolster, and I'm a partner and the head of science at leading climate tech fund, Lowercarbon Capital, where my colleagues and I spend our days evaluating the drivers behind that growth curve. I'm a PhD in chemical engineering. I've led research for many years in carbon capture and storage at Imperial College London and Stanford University. And today I invest in the leading companies building out the carbon removal market and many more. Let's take a look at this slide. On the y-axis, we have the total amount of annual greenhouse gas emissions, which includes CO2, that gray area under the curve, and other more potent greenhouse gases, that red area under the curve. And that's the projected emissions over time. In order to maintain temperatures below a 2 degrees C temperature rise compared with pre-industrial times, these emissions need to peak right about now before going down to zero in the next 50 years or so. Scientists and policymakers now refer to that 2 degrees C temperature rise threshold because it represents a sort of ceiling below which we can avoid the most dangerous impacts of climate change. In order to stay below that threshold, scientists have confirmed that because this rate of emissions isn't going down fast enough, and we've already emitted so much greenhouse gases, we need to counteract what will continue to be emitted. That's that green area below the x-axis. That's where that comes in. That's carbon dioxide removal. The exact amount of carbon removal that we need by 2050 has been estimated by the Intergovernmental Panel on Climate Change and the group of scientists behind it to be on the order of tens of gigatons of CO2 equivalent per year that needs to be drawn down from the atmosphere by 2050 at the latest. That's about 10,000 to 100,000 times more than what we do today. It sounds like a lot, because it is. The good news is, in this presentation, I'm going to be telling you about some of the technologies and companies that can make this possible. Because at Lowercarbon, we have over $2 billion to invest in and work with the companies that are slashing new emissions, sucking up carbon from the atmosphere, and buying more time to ensure that the planet remains habitable while these technologies scale up. I get special insight into all of this. Before we go any further, let's make sure everyone is on the same page, as there are lots of different terms that have just been introduced and that will be introduced. Carbon removal is shorthand for carbon dioxide removal, which can also be referred to by its acronym CDR. To be clear, carbon removal is different from carbon capture and storage. Carbon capture and storage specifically refers to capturing CO2 in places where it's very concentrated, like at industrial sites, at power plants, and then storing it in deep geologic reservoirs. Carbon capture and storage can be part of the carbon removal solution, but on its own is considered as a different thing. That'll become clearer as we continue in the lecture. A CDR credit. What is it? A CDR credit is the value received for drawing down carbon dioxide from the atmosphere, typically spoken of in dollars per ton of CO2 units. A carbon offset, something you may have heard of before, often in the context of planting a tree or protecting a mangrove somewhere in a distant part of the world, is not the same as a carbon dioxide removal credit. In fact, a carbon offset is typically issued upon purchase and does not require validation of the delivery of that carbon offset, which results in a skewed market. Contrary to a CDR credit, a carbon offset is not actually resulting in a net reduction in total CO2 in the atmosphere. Now that we know all about why we need carbon removal, here's some context for the terms around it. Let's reflect on how carbon moves around in our Earth systems. On the one hand, carbon moves between rocks, soils, the ocean, and the atmosphere through things like weathering, erosion, ocean sedimentation, the formation of fossil fuels, and volcanism. This is what we call the geochemical cycle. It moves carbon over thousands and millions of years. So we also refer to it as the slow carbon cycle. Those are these outward arrows that are going up and down and compensate for one another. The carbon cycle you're probably most familiar with is what's represented here in the inner black lines. That's what we call the fast carbon cycle. It moves carbon through the atmosphere, plants, living organisms, soils, and the surface of the ocean over days, years, through processes like photosynthesis, respiration, decomposition, combustion, ocean-atmosphere exchange. That fast carbon cycle has always been slightly imbalanced, and that's what has enabled the atmosphere to create a livable environment for humans. But then this new orange arrow comes in, which only goes one way right now, and it represents the human-induced carbon emissions that generate on the order of tens of gigatons of CO2 equivalent per year. And today, they're only going one way. They aren't being compensated in a large enough amount to make up for all that's pouring into the atmosphere. Now that you know how this works, I'm going to show you how and why we'll be making up for that arrow by pushing it into the slow cycle, and why that makes more sense over pushing it just into the fast carbon cycle. So what is the fast carbon cycle? It involves the movement of CO2 through trees, soils, and the ocean. These natural sinks are critical for many reasons beyond carbon, such as biodiversity, maintaining natural economies. They have a cost associated with them, and we should be doing all that we can to preserve and expand them, while being thoughtful about how we do it. But these natural sinks will reverse back to CO2 eventually, whether as a result of natural disasters or human involvement through burning or tilling. And then the CO2 just goes back into the atmosphere in a matter of years. There are ways to extend that to tens of years, and those are efforts that we encourage and back. But ultimately, it isn't aiding in the overall objective of getting a net amount of CO2 out of the atmosphere for millennia. Now you've understood why the fast cycle won't do it to move the bulk of that orange arrow. Let's talk through the ways in which we can move that orange arrow, the man-made emissions that are already up in the atmosphere, out into the slow cycle, and draw the carbon down for millennia, or what we might consider permanently, rather than just a few years. So there are four general buckets in the category of ways in which we can leverage that slow carbon cycle. The first one is air capture, where you use energy to pull carbon out of the air and then store it in deep geologic reservoirs or permanently stable materials like concrete. There's the use of biomass, where carbon is captured via photosynthesis, that becomes biomass, that biomass is processed, and then can be stored permanently. We can leverage the slow carbon cycle through mineralization by using reactive elements to bind carbon in mineral forms, or use minerals to accelerate the production of geochemically stable bicarbonate. And then we can leverage the oceans, grabbing what is a higher concentration of CO2 by about 10 times via things like direct ocean capture, or increasing the alkalinity of the ocean such that CO2 from the atmosphere is drawn down as a result. So what are the technologies that allow for moving more of that carbon into the slow cycle and out of the atmosphere for good? The first one that we'll talk about is direct air capture, or DAC. It involves the use of a sorbent reactive or non-reactive material, such as a solid or liquid or polymer, that will preferentially bind with CO2 over the other gases that are present in the atmosphere or air, like oxygen, nitrogen, argon. And then typically, using a form of energy like heat or electricity, that CO2 is stripped off of the sorbent to produce two things: CO2 depleted air and high purity CO2 that can be stored in forms that remain stable for thousands of years, like geologic reservoirs. Current costs of DAC remain fairly high, but with technological innovation, we expect that these technologies will come down to cost about $250 per ton by the early 2030s, in some cases perhaps even lower. The advantages include the fact that it's easy to measure how much CO2 is being drawn down, and there's a lot of certainty around the stabilization of CO2 below ground. Some of the disadvantages include the use of energy and relatively high cost of installment. The reason that the stabilization of CO2 below ground is so well understood is because it's effectively equivalent to the way in which we've stored so many liquids below the surface for millions of years, specifically fossil fuels. They've been there for a very long time, and it's effectively a very similar storage mechanism. Some of the companies working on this include Heirloom, Climeworks, 1.5. Lowercarbon's portfolio company is Heirloom, and they've been building out these facilities in the US and will be building many more of them. Bioenergy with CCS is another form of carbon removal, BECCS for short. It involves the sucking up of CO2 through photosynthesis, storing CO2 in biomass at first, and then processing the biomass, typically through some high temperature process like gasification or combustion, to produce electricity and high purity CO2 off the other end. In the same way as DAC, that CO2 is then stored in deep geologic reservoirs. This is one of the most commonly discussed forms of CDR. It was the placeholder in the scientific report by the IPCC and is pursued by many. The costs for BECCS are modest today, mainly because of the value of producing energy as well. And the expectation is for that to go down to something on the order of $100 per ton or lower by the 2030s. Advantages involve the co-benefit of producing energy as a byproduct that can be monetized, and the downsides include the sourcing of biomass waste and relatively inefficient combustion processes. Some of the new startups, like lower carbon portfolio company Arbor Energy, are working on innovations to this process that can make the overall process significantly more efficient, more compact, such that they can leverage a variety of biomass sources and the logistics become a lot less complicated. And then you have legacy energy companies like Ørsted and Drax getting involved, or developers like CO280. Globally, it's expected that at least billions of tons of waste biomass will be generated annually, whether this includes crop waste that's otherwise just burned or waste from the increasing need for forest fire management. And the result is billions of tons of carbon removal potential per year with this pathway. Bikers, only slightly different from BECCS, biomass carbon removal and storage. The main difference is in the end product. The end product is typically just a concentrated form of carbon, like a biomass slurry, bio-oil, or biochar that can be stored away permanently without contaminating anything above ground, or even serving as a form of agricultural input. The starting cost today is a little higher than BECCS just because of the novelty of some of the logistics, but is expected to come down very quickly as supply chains scale. Contrary to BECCS, some forms of bikers can process wet organic waste, of which there are billions of tons produced per year, with few other options to do anything with it aside from putting it in landfill that are overloaded. Some companies working on that include lower carbon portfolio company Volta Deep, that are storing biomass slurry waste in deep underground reservoirs and have the co-benefit of eliminating some toxic waste streams from landfills like PFAS, or forever chemicals. Other companies doing this kind of work include lower carbon portfolio company Charm Industrial, that miniaturize pyrolysis systems to produce bio-oil that can be used as an input for steel production or stored deep underground. Mineralization and enhanced weathering is another form of carbon dioxide removal with permanent timelines. It involves the acceleration of naturally occurring processes of weathering, where CO2 from the atmosphere reacts with minerals such as magnesium or calcium. This can be done by spreading fine forms of these minerals, which can be found which can come from rocks like basalt, and spreading them across agricultural lands, for example, or forests even. This reaction eventually converts CO2 into bicarbonate faster than the natural process would. And bicarbonate is a stable form of carbon that, when entering the ocean, helps boost alkalinity, raises the pH, in other words, and drives the chemical equilibrium further to the right and enables additional CO2 to be drawn down from the atmosphere. Mineralization specifically refers to the reaction of CO2 with magnesium and calcium minerals, forming stable carbonates, which in some instances can be in solid form. In the context of carbon sequestration, mineralization typically involves either accelerating this natural process or enhancing the capacity of rocks to capture CO2. Once in rock form, the reacted CO2 is considered stable for millennia, effectively returning carbon to that slow carbon cycle. The costs of these processes today are largely made up of the cost of measuring the movement of CO2 through these cycles and sampling soils at different parts of the process to understand how much has been moved around. But the process in and of itself should be relatively inexpensive and is expected to come down to about $100 or below by the early 2030s. This process involves a decent amount of logistics management, so many of the companies doing this work will have specific advantages in their ability to spread these rocks and measure them in their specific geography, such as Lowercarbon portfolio company Undo, based in the UK, and Lithos here in the US. And these can benefit agricultural output in some cases, replacing the use of things like limestone. ARCA, another lower carbon portfolio company, is enhancing the ability to draw down CO2 from the atmosphere by getting it to react faster and in larger quantities with mine tailings, of which there are millions of acres around the world. This also has the co-benefit of neutralizing those tailings that are otherwise just openly toxic and eliminating any environmental hazard that exists that is associated with the tailings. And that's a really, really strong and positive co-benefit associated with that kind of form of carbon removal. Other organizations working on this involve large organizations like BHP and possibly other agricultural companies or other quarry-owning companies. So now you know all about the great technology options and companies that are working very hard at this. Yet, the supply isn't meeting the demand. There are 10 times the number of buyers today than there were just 3 years ago, but they're scrambling to secure supply. And they know that they need it because policy is catching up with them. They've made big promises to their shareholders. This is part of their ultimate goals. And they know that whatever they wait to buy later will be more scarce and hence more expensive to access. In short, there's a lot of opportunity here. Plenty of different technologies and industries to work in, a variety of skill sets. And these technologies have been proven today. And now collectively, we need to work to get that billion-ton scale and ultimately unlock what is expected to be a trillion-dollar market. So now, do you believe my prediction? Not only is the market there, but this is one of the most impactful areas of work that you could consider embarking on. Thank you for listening.